We started off talking about the Pythagorean theorem. Okay, so the first thing we started off with. And when you deal with the Pythagorean theorem, you're dealing with the sides of a right triangle. Okay, we're dealing with the sides of a right triangle. We're not, the only angle that we're dealing with is that it has one right angle. That's all we're dealing with. Now, remember that it's not going to be perfect when I'm drawing this. Okay? So the Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. This is a leg. This is a leg. The legs are what touch the right angle. The hypotenuse is what is across from the right angle. Now, it's not perfect. So if I want to be able to find this, I would take the leg, which is 3. I would take the leg, which is 4, and the hypotenuse, which is x. 9 plus 16 equals x squared. 25 equals x squared. Take the square root of both sides, and I get 5 equals x. Now, normally when you take the square root of both sides, you're going to get plus or minus, but we're dealing with the length of something, so it's not going to be plus or minus. So let's pick another one. This time I've been given the hypotenuse, but one of the legs is not given. So I would say x squared plus 5 squared equals 13 squared. And when I do that, I get 25 equals 169. I subtract the 25 from both sides. I get x squared equals 144. So x, I take the square root of both sides, x equals 12. Now these are ones that come out nice and pretty. Not always are they going to come out nice and pretty. I'm just going to pick random numbers. We're going to pick 5, 7, and I don't have a clue. So 5 squared plus 7 squared equals x squared. So look at 25 plus 49 equals x squared. Now hopefully you're able to add quick enough. Not everybody can add quick, that's fine. Now, sometimes your teacher is going to ask for what is called an exact answer, and sometimes your teacher is going to ask for you to round to the nearest whatever. Now, when you're trying to find the exact number, you would leave it as a simplified square root. Now, 74 is the same thing as taking 3 times 37. Neither one of those are perfect squares, so that is going to be the exact answer. Now, if you have a teacher that's asking you for you to round it to the nearest tenth, then you would get 8.6 is approximately x. I, for the most part, will ask for the exact answer. I will not be asking for the rounded number. I like it better with the exact answers. Okay, the other thing that we talked about was your trig functions. Okay, we talked about trig functions. when we talked about the trig functions, it deals with not just the sides, but also the angles. Okay? Sides and angles, not just the side. It also has to be a right triangle, at least for now. For what we're doing, it has to be a right triangle. Okay, so when we're dealing with this, if I'm going to talk about this angle right here, if I'm going to talk about that angle, I'm actually going to make this bigger. Okay, this is always going to be the hypotenuse. That is always going to be the hypotenuse. Now, the other words that we talk about is this right here is next to that angle. So it's an adjacent leg. It is an adjacent leg. Now this one doesn't touch that angle at all. This is an opposite leg. So there are 3 trig functions that we're going to talk about in this. There's more than 3, but we talk about 3 specific ones. We talk about sine, and we're going to name this A, B, C. So if I'm talking about sine A, anytime you talk about sine, you're talking about opposite leg over the hypotenuse. Okay? If I'm talking about, I did not mean to do that, cosine of A, we would be talking about the adjacent leg over the hypotenuse. And if we're talking about the tangent of A, we would be talking about the opposite over the adjacent. The opposite over the adjacent. Now sometimes people make this into an acronym. We have S, O, H, C, A, H, T, O, A. SOHCAHTOA. A lot of times I don't do it that way, but that's just me. You can do it that way if you want. Now, remember that when we're trying to deal with angles and sides, we are going to use these trig functions. So I'm going to draw this right triangle. I know it's not pretty. I'm going to say that this angle is 43 degrees. I'm going to say that this is 9 centimeters long, and I want to find the hypotenuse. Okay, so this is a cross. It's not touching, so we have the opposite, and we have this x is at the hypotenuse. Okay, opposite over hypotenuse. So which one of these trig functions are we going to use? Which one has opposite and hypotenuse? If you notice, it's going to be the sine. So we're going to do the sine. Now, we don't need to put a letter because it actually gives us what the degree measure is. It gives us 43 degrees. We're looking at the opposite. So what's opposite of the 43? A 9 is. The hypotenuse is an x. Okay, so now we need to solve that. That means we need to get the x all by itself. Okay, we're going to put that over 1. I'm going to change the color for a second and show that we are going to cross multiply. We're going to put x out in front of the sign 43. That automatically tells you that it's multiplication when it's written like this. And then 9 times 1, which is 9. But we still don't have the x by itself. We need to get the x by itself. In order to do that, I'm going to divide by sine 43 degrees. Divide by sine 43 degrees. So I get x equals 9 sine 43 degrees. Now, if you use the Desmos calculator, desmos.com/scientific, then you just put this in exactly how it's written. If you are using a calculator like your phone or one that doesn't have a display, whatever it's called, a display window, you have to do kind of a backwards thing when you plug it in. Okay, so if you're using your phone calculator, you're going to write 9 divided by, I did not mean to say right. You're going to plug in 9 divided by, then you're going to put an open parenthesis and put 43. Okay, so you're going to open parenthesis it, 43. Then you're going to hit the sign button. Close the parenthesis. Oops, I didn't mean to do that. Close the parenthesis. And hit the equal sign. So I just accidentally 9 divided by 43 sine, and you would get 13.19. So x is approximately 13.19 centimeters. Okay. So we're going to do another one. When I do this one, I'm going to pick, I don't know, 12, 15, and I want to find this angle right here. So when I do this, I have this angle right here, and I notice that the 12 is adjacent. The 15 is the hypotenuse. So if I come back up here and I look for adjacent over hypotenuse, I would come up with cosine. So we're going to be dealing with the cosine. So I write cosine, and we don't know what the cosine measure is, or the angle measure is, equals 12 over 15. How did I get 12 over 15? It says adjacent, and the 12 is adjacent because we're talking about the adjacent leg, where the hypotenuse is this one right here. So, in order to find the angle measure, we actually have to write it a different way. What we have to do is we have to write the inverse of cosine. We're writing the inverse of cosine. Now, if you're using the Desmos calculator, you hit the little function button and you'll find cosine -1. Then you just write 12 over 15 and hit the equal sign. If you are using your phone calculator, you would hit, let's see, 12 divided by 15. You want to write 12 divided by 15 and then hit the equal sign. And then you're going to hit the second button, and then you're going to hit the cosine -1. And I just messed up. So 12 divided by 15, hit the equal sign, hit the second button, and hit cosine, and you would get x is approximately 36.9 degrees. Okay, let's try another one. Okay, I want to find, I'm going to say that this is 39 degrees. Oopsie daisy. This is 8. And I want to find this right here. So, we've been given the angle measure. We have opposite and we have adjacent. How did I know they were opposite and adjacent? Well, one, they make the right angle right here. They both touch the right angle. But it's not the hypotenuse because the hypotenuse is across from the right angle. This right here is the hypotenuse. There, we don't have any information there. So we don't need that. So that means we have tangent of 39 degrees. That's going to equal x, because x is opposite of 39 degrees, and then next to it, which is 8. So in order to finish this problem, I need to cross multiply. So I get 8 tangent 39 equals x. So you put it into your calculator. 39 tangent. Okay. So what you're going to do, if you have it in your Desmos calculator, you just put it in just like that. If you have the phone calculator, then you're going to put 8 times 39 tangent equals. And you should come up with x is approximately 6.48. And that is going to be, well, let's say that it's centimeters. So we'll call it centimeters. Now, again, it's approximation. It's not an exact answer because we had to round our answers. Okay, I'm going to do another one. X 12 degrees and 25. Okay, so this is dealing with the adjacent and the hypotenuse. So that's going to be the cosine of 12. This dealt with the adjacent and the hypotenuse. Okay, so the adjacent for this is 25. The hypotenuse for this is x. Again, we have got to get that x by itself. So I write that over 1 and I do cross multiplication. I would get x cosine 12 equals 25. We need this x to be by itself, so I need to get rid of the cosine 12. Right now they're multiplied together, so I divide by the cosine 12. When I get that, I get x equals 25 over cosine 12. If you have the Desmos calculator, you put it in just as it is. If you have the phone calculator, you would say 25 divided by parenthesis 12 cosine equals 25 divided by 12 cosine equals. So that x would be approximately 25.6, we'll call them meters this time. Meters. Oh, and that would be approximate, not equal to. Okay.